two main things that we're going to talk about today are two different formulas, distance formula and midpoint formula. So like I told us, these notes are a lot less notation and more numbers. First thing is some vocabulary, and it is a segment bisector. Okay, segment bisector. First thing I want to talk about is, what does the word bisect mean? Bisect just means to cut in half. So bisect is the idea of cutting in half. So when we say segment bisector, we are bisecting a segment. So we are cutting a segment in half. So a segment bisector is any object that divides a segment into two congruent, and remember, congruent just means equal parts. So any object that divides a segment into two congruent or two equal parts. Okay. So a segment bisector can be a segment, another segment. It can be a line. It can be a point. It can be a ray. So the example we have, it's a line. But a point can be a segment bisector. Another segment can be a segment bisector. Okay, so some things that we notice from the figure. First thing, we have a segment, AB. We cannot cut a line in half. So a line cannot be cut in half because it has infinite length, but a segment can. How do we know that these two are equal? How do we know on the figure that AM and MB are equal? Okay, thank you.
The lines.
Okay, the tick marks. So these tick marks, if you remember, mean that they are equal. So that tells us that AM and MB are the same. And if we look at what's written, congruent is this symbol, if you remember. So the equal sign with the tilde over it. Do we remember from last class, or even just from looking at earlier on this page, what this point is called? If it's directly in the middle of the segment? Midpoint. Manny, is that what you were going to say? So a segment bisector will always go through the midpoint because the midpoint is in the middle. Okay, let's do some examples. So identify the segment bisector, and then this should say calculate PQ. Okay, so if we look at the first one, like Kai told us, these tick marks mean that they are equal. So what that tells us is that our segment bisector is this ray MN. Notation-wise, the ray starts at M and heads towards N. So starts at M, heads towards N. Okay, so if we know that this part is 1 7/8, then this part is also 1 7/8. So PQ then will be the total. So it's 1 7/8, add 1 7/8, which is 2. What is 7/8 add 7/8? (14/8 or 16? Do I add denominators? No, thank you. 14/8. So that simplifies to 7/4. 7/4 is 1 3/4. Once I add my 2, I get 3 3/4. Or I can also write it as 15/4. either one of those. Second one that we're going to do, our segment bisector. We got to be careful here. Is this L a point? Is that L that I just circled a point? No. So the only way we can call this is line L. We cannot take that L and put a line over it. We also cannot say that it's LM because L is not a point. Only thing we can say is line L. So again, these tick marks tell us that we can set these equal. So we have 5x subtract 3 is equal to 11 subtract 2x. That's what we're going to solve. Okay, if I start by moving the 2x over. 5x add 2x is 7x. If I move the 3 over, I get 7x is equal to 14. So divide by 7 and x equals 2. If I substitute 2 back in here, so I have 5 times 2 minus 3. So 10 subtract 3, so 7. Do I even have to bother plugging 2 back in here? So I plugged 2 into here. Do I have to plug 2 into here also? We already know they're equal. So if this is 7, this has to be 7, which means PQ has to be 14. Questions before you do a few? Okay. What you are going to do is the next two, you will identify the bisector and then calculate the entire length. So I want you to take a few minutes to do that with the person next to you. So if you have not moved your desk with them, please do so and give those next two a try. Okay, so for the first one, the segment bisector should be point M. Is there any other way that we can write this bisector? Is there any other way to express point M? No, there's not. If both sides are 2 and 2/7, then all of PQ is 4 and 4/7, and that is it. Second one, the bisector is line N. That is the only way to write this because N is not a point, so we can't use M. So it's line N. If we set 4x plus 3 and 6x minus 12 to be equal, we should get x to be 15 over 2 or 7.5. I said you could use a calculator if you wanted. What I wanted you to see is how Charlie did this without a calculator. So what he did is he plugged this 15 over 2 into 4x plus 3, and it is possible to multiply by 4. So if we remember multiplying by a fraction, this is really 4 over 1. So 4 times 15 is 16, 1 times 2 is 2. So notice that even though you got a fraction or a decimal for x, our whole answer, or our answer is still a whole number. So you get 33 for half of it, so the whole thing then, RS, should be 66. How did this go for us? Okay? Lovely. Any questions on what we've done so far? Okay, so let's move on. We're moving on to midpoint and distance. Okay, midpoint formula. Let's say that you have a segment like this, and it is segment AB, and point A is x1, y1, and point B is x2, y2. So you have coordinates for A and B. And then we have some midpoint in the middle, M. The way I know it's a midpoint is I'm going to put tick marks. The way that I find that m is I'm going to add the x coordinates. And I'm going to divide by 2. I'm going to add the y coordinates, and I'm going to divide by 2. Okay, so let's do some examples. This first example, we have the 2 points. We are finding the midpoint. All we do, add the x values. So -3 add -1, and then we're going to divide by 2. Add the y values. So 6 add -4, and I'm going to divide by 2. What do I do first, the adding or the dividing? Okay, so here is the thing that is kind of tough with a fraction. It's kind of like there are parentheses here that are just understood to be there. So we're going to have to calculate the numerator before we can divide. So -3 add -1 gives us -4. And then we get a 2. When we divide by 2, then we get -2, 1. So that would be the point halfway between A and B if we were to plot them. I don't think we need to do the exact same thing again, do you? Do you think we don't need another of the exact same example? We do need to do this one, though. So this last one is different. Given the midpoint is 4, 6, and point A, find the end point. Okay, so here is what we have. Let's take a look at a picture. We have AB. We know that A is -1, 3, and we know the midpoint is 4, 6. Now, I'm going to put tick marks to show that this is the midpoint. We need to find point B. This is not the same as what we did above. So it is not the exact same as what we did above. Same idea, though, or a similar idea. We need to find the other end point. I don't know that point, so I'm going to call it XY. The midpoint formula above that we wrote in red says add the x's and divide by 2. Add the y's and divide by 2. We're not doing it for these 2 points. If we do it for these 2 points, all we're going to do is find the midpoint in between them. That's not what we're doing. We always use the 2 endpoints. So we're going to do that midpoint formula above using the endpoints. We're not using this 4, 6 yet. Okay, so if I add my x's, that's -1 add x, then I divide by 2. Add my y's, that's 3 and y, then I divide by 2. When I do that, I already know the answer I'm going to get is 4, 6, because that's the midpoint. Now, we have 2 unknowns, x and y. If we have 2 unknowns, we're going to need 2 equations. It makes sense to set our x's equal, and then to set our y's equal. So our first equation then for x's in yellow is -1 plus x over 2 equals 4. The one for y is 3 add y over 2 equals 6. You had something very similar to this on the algebra review that you did. Does anybody remember, if I go to solve for x, what I can do first? Solve for none?
Is it multiply by 2?
Okay, beautiful. I love that. Right now we're dividing by 2. Thank you. Opposite of that is to multiply by 2. So when we do that, those 2's will cancel. And on the left side, we just have -1 plus x. And on the right side, we have 8. So we have to remember we're multiplying by 2 over there also. So when we add 1, we're going to get x equals 9. Same thing for the y, multiply by 2. So we get 3 plus y. When we multiply by 2, we get 12. So when we subtract the 3, our y equals 9. Ooh, that's so nice. So that endpoint B ends up being the 0.99. Okay. For your examples, I don't want you to do this one, just because it's repetitive. I want you to do those next two, please. So with the person next to you, find the midpoint, and then similar to what we did, you're given the midpoint, find the endpoint. Okay, this is what I got. Do you all agree for the first one, -3/2 and -3/2? Can anybody? Yes? Yeah, I would prefer that we just leave it as fractions. But I know some of us don't like fractions, so if you want to leave it as decimals, that's fine also. Okay, I would highly suggest a figure of some type for the last problem. So -2/3 is the midpoint, not the end point. So when you're using the formula, these are the points you should be adding, setting them equal to the midpoint. So that's what I did over here. You then are setting your x's equal and your y's equal. So what I'm doing here, well, you tell me. This first line with the x, how did I go from -2 to -4? Ryder? How did I go from -2 to -4?
Because you multiplied 2.
Multiplied by 2. Multiplied by 2. Now, we should be able to do a quick mental check on our answer. So let's do that real quick. So this is 1, -1. So if we go back and use the midpoint formula, if we take our x's and we add them and divide by 2, and we take our y's and we add them and divide by 2, do we end up with our midpoint? Well, what is -5 add 1? -4 divided by 2 gives me -2. 7 add 1, -1 is 6 divided by 2 gives me 3. So you always should be able to do that to make sure your answer works out. How did that go? Okay? We got, let's say, 10 minutes, and we'll try to finish this. Questions for me before we move on to distance formula? Okay, let's do the distance formula real quick and then be done. Distance formula helps us find the distance between 2 points. Helps us find the distance between 2 points. You are subtracting your x's, squaring it, subtracting your y's, squaring it. But then because you squared it, you have to take the square root. I think it's best just to see this in action. So we are going to find the distance between points A and B. So this point, A, I'm going to call x1, y1. B is going to be x2, y2. But practically, it doesn't matter the order you're subtracting in. So if I do my distance formula, I'm going to start with x2 minus x1. So I'm going to have 4 subtract 2, and then I'm squaring. You have to remember you're subtracting. And then for my y's, I start with the same y, -1. I subtract the other y and square it. So keeping in mind order of operations, we're going to have to do the parentheses first. So I end up with 2, and then this is really a -4. Then I can square. So 2 squared is 4. -4 squared is positive 16. So this ends up being the square root of 20. I do want that simplified. So I do want that simplified. What perfect square goes into 20? 4. So this is the square root of 4 and the square root of 5. The square root of 4 is 2. So we get 2 root 5. Now, 2 root 5, I don't know about you, I look at that, I really have no idea what that number is. So sometimes it's nice to get a decimal also so we know approximately how far apart those are. That is about 4.47. I want us to write this down, please, this next part. This, before it goes into the calculator, is called your exact answer. This answer, after it comes out of the calculator, is your approximate. Last thing we're going to do today is this last problem, and it's the one that you're going to do. I would like, please, both the exact answer and the approximate answer, and please label them. So please find the distance and label the exact and approximate answers. Okay, can we look up here, please? So if we could quiet down and look up here, we should get the square root of 85. That does not simplify. So if you look up here, the only two numbers that go into 85 are 5 and 17. So nothing else goes in. If you look at my setup, it doesn't matter which x you start with. I started with the positive one. You have to remember you're subtracting. This negative does not count as subtracting. So it is 4 subtract negative 3, which gives us a positive 7 to square. Here then, negative 1 subtract 5. Negative 6 squared is positive 36. And then we have to remember at the end you're adding, not subtracting. So a lot of you had the right idea, and a few of you got the root 85, which is great. While I talked a lot today, I feel like we didn't cover as much stuff as we did last class. Just the 2 formulas and the idea of a bisect. I cannot stress enough, I expect you to show work on your homework. Please do not just give answers, because you will not get credit. Any questions for me?